Udhampur. Okay, we start the second session now. Done operation on sets. Operation on sets or set operation. The different types of operations are union, intersection, difference, and complement. First of all, write down union of sets. Write down let capital A and capital B be two sets then A union B is denoted as A union B. This is the symbol for union, that is U, and the connective for union is R, okay, which is defined by A union B is the set of all X such that either X belongs to A or X belongs to B. Either X belongs to A or X belongs to B. So union B contains the elements, those are elements of A and elements of B or elements of B. For example, let A be the set containing the elements alpha, beta, gamma, and B be the set containing gamma, delta, theta. Okay. So in A union B, we should write all the elements of A and B. That is, A union B contains alpha, beta, gamma, delta, theta. Right? Another example, let A be the set 2, 4, 6, and B be the set containing the elements 1, 3, 5. So A union B is the set 1, 2, 3, 4, 5, 6. I hope it is clear to you. Write down a note point. So you see, if you choose an element from the set A union B arbitrarily, and that element may be the element of set A, or it is the set of B, or set of both A and B. Okay. So note it down. If X belongs to A union B, if X is an element of A union B, this implies that either X is an element of A or X is an element of B. X belongs to A union B implies that either X is an element of A or X is an element of B. Second note point, if X is not an element of A union B, if X is not an element of A union B, this implies X doesn't belong to A, X doesn't belong to A, and X doesn't belong to B. Okay. Then how to represent union of two sets in diagram diagrammatic representation of a set is known as Venn diagram. Venn diagram. So in Venn diagram, the general normal sets are represented by circular region, and universal set is represented by rectangular region. If A and B are two sets, suppose this is set A, this is set B, where no elements are common in A and B. So A union B is the all the elements of A with all the elements of set B. The shaded region represents A union B. If some elements of set A are common to some elements of set B, common to A and B, then A union B is the Venn diagram of union of two sets. In third case, this is case 1. This is case 2. In case 3, suppose one set is contained in another set. That is, suppose A is subset of B. So A is contained in B. This is will be the set A union B. Okay. So write down the shaded region represents A union B. Shaded region represents A union B. Shaded region represents A union B. Right? So guys, from the figure, tell me in which case A union B will be maximum. Tell me in which case A union B will be maximum, in case 1 or case 2 or case 3. In which case A union B will be maximum. In case 1, the A union B will be maximum in case 1. This is maximum case. And this is minimum case. A union B is minimum in third case. A union B maximum in first case. This is minimum. Okay, write down some properties of union of sets. Write down properties of union. Properties of union. Property 1, A union A is equal to A. Union is idempotent. Property 2, for any two sets, A union B is equal to B union A. A union B is equal to B union A. Union is commutative. For any three sets, A, B, and C, A union B, union C is equal to A union B union C. This property says that if you want to get the union of three sets A, B, C, then take the union of any two sets first, then take the union with the third set. Okay. So for union of A, B, C, we take the union of A and B first, then we will unite it with C. Then property 4, A union phi is equal to A. A union phi is equal to A. Then property 5, A subset, if A subset of B, then A union B is equal to B. If A subset of B, then A union B is equal to B. Property 6, if cardinality of A is equal to M, number of elements in set A is equal to M, and the number of elements in set B is equal to N, then maximum value of cardinality of A union B is equal to M plus N. This is possible only when no elements are common in two sets, and minimum value of cardinality of A union B will be the maximum of max M and N, means the greater among the two. And this is possible only when one set is a subset of the other set. When one set is a subset of the other set, union of the sets will be minimum. When there is no element in common in two sets, then A union B will be maximum. These are all 6 properties of union, right? Guys, union is over. Then come to intersection. Is it clear, guys? Please write in the chat box. Is it clear? Did you understand? Pratisha, Priyanka, Krishnamayi. Okay, then come to intersection of sets. Intersection of sets. Just a minute, guys. Break చెప్తున్నా break ଏସବୁ ସାଙ୍ଗମାନଙ୍କୁ ଜଣେଇଲେ ସବୁ ତମକୁ ସବୁ ନୋଟ୍ ଫୋଟ୍ ପ୍ରୋଭାଇଡ୍ ହବ, POI ପ୍ରୋଭାଇଡ୍ ହବ, ତାର ସଲ୍ୟୁସନ୍ ପ୍ରୋଭାଇଡ୍ ହବ। ଆଉ ଯାହା ଯାହା ଡାଉଟ୍ ଅଛି ଆପଣଙ୍କ ନମ୍ବର ଦେଇଦେବେ, ମୋ ନମ୍ବରରେ ଡାଉଟ୍ ପଠେଇଦବ। କନଫିଡେନ୍ସ ନେବେ। ପିପିଟି ସାର୍ କଲେ ବେଟର। ମ୍ୟାଥ୍ ପିପିଟି କଣ? ମ୍ୟାଥ୍ ସବୁ ଲେଖିବାକୁ ପଡ଼ିବ। ପିପିଟି କଲେ ବି ଆପଣ ତାକୁ ସବୁ ସେଇ ଯୋଉ ଟପିକ୍ ମୁଁ 6ଟା ଲେଖିଲି। ପିପିଟି କଲେ ଟିକେ ଇଣ୍ଟରାକ୍ଟିଭ ହବ ବେଶୀ ଟିକେ। ମୁଁ ଟିକେ କମ୍ପ୍ୟୁଟର ନଲେଜ କର ତାପରେ କରିଦେବ। ପିପିଟି ମାନେ POI ଗୁଡ଼ା କୋଚିଂ କରିଦେବି। ମାନେ କଣ କହିଲ ପିପିଟି ଥିବ, ପିପିଟି କ୍ୱେଶ୍ଚନ୍ ଥିବ, ବ୍ଲାଙ୍କ ଥିବ। ଆପଣ ଏଠି କରିବେ, ଏଠି ସଲ୍ୟୁସନ୍ ଦେଖିବେ। ହଁ ସେଇଆ କରିବା। କରିଦେବା। ଜାଗା ଥିବ ଯେମିତି ହ୍ୱାଇଟ୍ ସେଠି ଗାଡ଼ ହେଇଛି, ସେଠି ସଲ୍ୟୁସନ୍ ଦେଖିବେ। ସେ ପରେ ଇମ୍ପାକ୍ଟ ପଡ଼ିବ। ପିପିଟିର ପେନ୍ଡ୍ରାଇଭ୍ ଆଣିବାକୁ ପଡ଼ିବ। ହଁ ପେନ୍ଡ୍ରାଇଭ୍ ଆପଣ ମୋତେ ହ୍ୱାଟ୍ସଆପ୍ କରିଦେବେ। ଆଡ୍ରୁ କହୁଥିଲେ କଥା। ପିଲା ଟିକେ କଥା ହେଇଯାଆନ୍ତୁ। ତମ ସାଙ୍ଗମାନଙ୍କୁ କୁହ ସବୁ କ୍ଲାସ୍ ଗୁଡ଼ା ଆଟେଣ୍ଡ କର। ପିପିଟି ଦିଆହବ, କ୍ୱେଶ୍ଚନ୍ ବ୍ୟାଙ୍କ ଦିଆହବ, ଡାଉଟ୍ ଦିଆହବ, ଯାହା ଯାହା ଡାଉଟ୍ ଅଛି ତାଙ୍କର ମିଟିଂ ନିଆହବ। ନେକ୍ସଟ ଷ୍ଟୁଡେଣ୍ଟ ଫିଡବ୍ୟାକ୍ ନିଆହବ ଲାଇଭ୍ କଥା ହେବା। ମ୍ୟାଥମେଟିକ୍ସର ଫାଷ୍ଟ କ୍ଲାସ୍ ତ ହେଲା ଆଜି ଆଉ। ସରିଯିବନି ଦେଖିଲି ତ ଏଇଟା ଆସିଲାନି ତମକୁ କଣ ବନ୍ଦ ହେଇଗଲା ସେଠୁ ଇସ୍ୟୁ ଥିଲା। Okay, then come to intersection of sets. Oh, last property again. The last property is about the number of elements in the set A and B. It is given that the number of elements in set A is equal to M and the number of elements in set B is N. We have to find the maximum value of A union B. So the maximum value of A union B will be maximum only when there is no element common in the two sets. Number of elements in set A is M and the number of elements in the set B is N. Suppose A set contains the elements A1, A2, A3 up to AM, A set contains the set elements A1, A2, A3 up to n. N number of elements are there. And B set contains n number of elements. B set contains suppose B1, B2, B3 up to Bn. Now tell me what will be A union B? A union B is equal to A1, A2, A3 up to Am, comma B1, B2, B3 up to Bn. So the number of elements in A union B is m plus n. Because since no element is common to both the sets, if an element is common to both the sets, that will be counted once, not twice. Okay. So since no elements are common in set A and set B, the A union B will be maximum only when there is no element common in M and A and B. So the number of elements, so max value of, max means maximum, max value of any number of elements in A union B is equal to m plus n. I hope it is clear to you now. Priyanka, is it clear? Write in the chat box, is it clear, Priyanka? Okay, then come to intersection of sets. Intersection of sets, let the intersection of, the intersection of the sets A and B, the intersection of the sets A and B is denoted by the intersection of the sets A and B is denoted by, this is the symbol for intersection, reverse U, and the connective for intersection is AND. Connective for union is OR, connective for intersection is AND. The intersection of the sets A and B is denoted by this, which is defined by, which is defined by, which is defined by A intersection B is the set of all x such that A intersection B is the set of all x such that x belongs to A and x belongs to B. A intersection B is the set of all x such that x belongs to A and x belongs to B. That means intersection of two sets contains the elements, those are common to both the sets. Intersection of two sets contain the elements, those are common to two sets. For example, let A be the set, let A be the set containing the elements 1, 2, 3, 4, and B be the set containing the elements 3, 4, 5, 6. B be the set containing the elements 3, 4, 5, 6. Then what will be A intersection B? Then the set A intersection B is the set containing 3 and 4, right? So 3 and 4 are common to both the sets A and B. Come to another example, let A be the set containing alpha, beta, gamma, and B be the set containing the elements delta, theta. A be the set containing the elements alpha, beta, gamma, and B be the set containing the elements delta, theta. Now tell me what will be A intersection B. Here no element is common to both the sets, hence A intersection B is null set. If A intersection B is a null set or A intersection B is equal to phi, then A and B are called disjoint sets. Note it down. If A intersection B is equal to phi, then A and B are called, then A and B are called disjoint sets. Then A and B are called disjoint sets. If A intersection B is equal to 5, then A and B are called disjoint sets. No elements are common. Okay. Then you see here the A intersection B set contains 3, 4. If you choose an element arbitrarily from the set A intersection B, it will be an element of set A as well as set B. So we should write it in a note. If X is an element of A intersection B, X belongs to A intersection B, implies and implied by X belongs to A and X belongs to B. Okay. Here one doesn't belong to A intersection B. That means either one doesn't belong to A or one doesn't belong to B. So the second point, X doesn't belong to A intersection B implies that either it is not an element of set A or not an element of set B. So this implies X doesn't belong to A or X doesn't belong to B. Right? This is about intersection. Then come to Venn diagram or diagrammatic representation of the intersection of two sets. Diagrammatic representation of intersection of two sets. And means both are included. So we should write and for intersection because they belong to both the sets. Okay. The elements belong to both the set. 3 belongs to set A and also 3 belongs to set B. 4 belongs to set A and also 4 belongs to set B. That's why we are writing and. If doesn't belong to sign is there instead of and. Sorry. Here I have done a mistake. It doesn't belong to A intersection B. If it doesn't belong to symbol is there, then you should write the connective or. The connective for intersection is and. Then come to Venn diagram of intersection. Case 1. There is no element common to both the sets. So this case is the minimum case for intersection. These are two disjoint sets. No elements are common to both the sets. Case 2. Partial overlapping sets. That means some elements are common to both the sets. This is set A. This is set B. This shaded region represents A intersection B. This is the set A intersection B. Okay. Then case 3, total overlapping case. That means one set is contained in another set. One is the subset of another. Here A is the subset of B because set A is entirely inside set B. Here the A intersection B is the set A. And the third case is the case where the A intersection will be maximum. And first case is the case where A intersection B is minimum. Write down here A intersection B is maximum. Here A intersection B is minimum. A intersection B is minimum. So in first case, A intersection B is minimum. In second case, in the third case, A intersection B is maximum. Then shaded region represents A intersection B. Clear? Then come to properties of intersection. properties of intersection. Properties of intersection. Properties of intersection. Right? Property 1. A intersection A is equal to A. Property 2, intersection is commutative. A intersection B is equal to B intersection A. This is commutative law. Then third is intersection is associative. For any three sets ABC, A intersection B whole intersection C is equal to A whole intersection B intersection C. This is associative law. In Odia, this is called Krama Binimoyi, this is called Sahajogi. Okay. The fourth one, A intersection phi is equal to phi intersection A is equal to phi. A intersection phi is equal to phi intersection A is equal to phi. Null set. Property 5. If A subset of B, then A intersection B is equal to A. If A subset of B, then A intersection B is equal to A. Property 6. If cardinality of A is equal to M and cardinality of B is equal to N, then minimum value of cardinality of A intersection B, minimum value of cardinality of A intersection B is 0. This is the case where the two sets are disjoint. This is suppose set A, this is set B. No elements are common to both the sets. Hence, you can say that 0 number of elements present in A intersection B. No A intersection B is phi, and null set, cardinality of null set is 0, and max value of A intersection B, max value of A intersection B is the minimum of M and N. Minimum of A and N means smaller among the two. Smaller among the two. This is the case where one set is contained in another set. If A is a subset of B, then eventually number of elements of A is less than number of elements B. And this is the case where the A intersection B will be maximum. Okay. If A is the subset of B, suppose A contains M number of elements and B contains N number of elements, here A intersection B is equal to M. Okay, this is the minimum case. I hope it is clear to you. Did you understand, guys? Please write in the chat box. Okay, let's move forward. Then there is a property involving a union and intersection. That property is called distributive property. In ODI, it is known as Bantoniyam. Okay, distributive property. And multiplication is distributive over addition. That is A into B plus A into B plus C is equal to A into B plus A into C. This is called a distributive property, right? Similarly, you can use distributive property using union and intersection. The property says that, write down distributive property. Distributive property. The property says that union is distributive over intersection. Union is distributive over intersection. Union is distributive over intersection. Shreyas Monica case 1. Okay. Union is distributive over intersection, that is A union B intersection C is equal to A union B intersection A union C. A union B intersection C is equal to A union B intersection A union C. The second case is intersection is distributive. Intersection is distributive over union. That is A intersection B union C. Intersection is distributive over union. A intersection B union C equals A intersection B union A intersection C. A intersection B union C equals A intersection B union A intersection C. Union is distributive over intersection. The second one is intersection is distributive over union. Okay. So, written question. Take the sets. Let A be the set. 1, 2, 3, 4. B be the set. 4, 5, 6, 7. And C be the set. 1, 3, 5, 8, 9. Prove that using the sets ABC, prove that A union B intersection C is equal to A union B intersection A union C, and second, verify that A intersection B union C equals A intersection B union A intersection C. Okay. So guys, take 2 minutes of time and verify the part 1 and part 2 both. Over, verified. Then come to different subsets. Different subsets. Let A and B let A and B be two sets. Let A and B be two sets. Then A difference B then A difference B is denoted by and which is defined by A difference B is the set of all X such that X belongs to A and X doesn't belong to B. X belongs to A and X doesn't belong to B. A difference B contains the elements those are belongs to set A but doesn't belong to set B, or we can say that the elements those are present in set A but not in set B. For example, suppose A be the set containing the elements alpha, beta, gamma, and B be the set containing the elements gamma, delta, theta, and B be the set containing the elements gamma, delta, theta. Here, A difference B is the element those who belong to set A but doesn't belong to set B. Alpha belongs to set A but alpha doesn't belong to set B. So alpha can be taken in set A difference B. Beta belongs to A and beta doesn't belong to set B. So beta can be taken in the set A intersection B, not gamma, because gamma present both A and B. Again, B difference A is equal to the elements those are present in B but not in A. Gamma belongs to B, but gamma belongs to A. So gamma should not be taken in B difference A. Delta belongs to B and delta doesn't belong to A. So delta should be taken in B difference A and theta also taken in B difference A. So from this illustration, it is clear that A difference B is not equal to B difference A. Okay. Then come to Venn diagram of A difference B. This is suppose set A. This is set B. This region is A difference B. And this region is B difference A. And this region is called A intersection B. Okay, then come to properties of difference. Properties of difference of two sets. Property 1, A difference A is equal to phi. Property 2, A difference B is not equal to B difference A. Property 3, A difference B whole difference C is not equal to A difference B difference C. Property 4 and 5. You see, this is A difference B. This region is A intersection B. And this region is B difference A. A difference B union A intersection B is equal to A. A difference B union A intersection B is equal to set A. Property 5, B difference A union A intersection B is the set B, right? Then come to universal set and complement of set. Universal set and complement of a set. First write down universal set. The largest set over a special discussion is called the universal set and all other sets in that discussion are subsets of the universal set. Are subsets of the universal set okay. Generally, universal set is denoted by U. Universal set is denoted by U. And in Venn diagram, it is represented by a rectangular region. It is represented by a rectangular region like this. This is the universal set U, and all other sets are subset of the universal set A, B, C, etc. Okay. For example, let us come to example. Let A be the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B be the set containing the elements 1, 3, 5, 7, 9, and C be the set containing the elements 2, 4, 6, 8, 10. Now tell me, among these three sets, which set should be considered as the universal set? The largest set. The largest set is S is the universal set, and B and C are subsets of A. So here A should be considered as the universal set. Okay, in a special discussion, the largest set should be considered as the universal set. Okay. And all other sets are subsets of the universal set. Then write down complement of a set. Complement of a set. Write down let U be the universal set. Let U be the universal set and A be a subset of U. Then the complement of A then the complement of set A, then the complement of set A is denoted by A prime or A raised to the power C, A complement, which is defined by A complement is the universal set difference A set. Universal set difference A set. For example, let universal set be 1, 2, 3, 4, 5, 6. A be the set 1, 2, 5. Then what will be A complement? A complement is U difference A, that is 3, 4, and 6. Okay. This is the universal set, and A be a subset of universal set. The shaded region represents a complement. Shaded region represents a complement or complement of A. Okay. Hello. हम जाऊँ हाँ ମୁଁ ଯିବି 10:30 ଏବେ ଗଭର୍ଣ୍ଣମେଣ୍ଟ କ୍ଲାସ ନଉଛି Okay. Then come to properties of complement. Properties of complement. This is the universal set U. A is the subset of U. This is A, and this region is a complement. Okay, properties of complement, write down. A union A complement is the universal set. Then there is no element common between A and A complement, so we can write A intersection A complement is equal to phi. A intersection A complement is equal to phi. The another two properties are there, which is known as De Morgan's law. De Morgan's law. Write down, let U be the universal set let U be the universal set and A and B be two subsets of U. Let A and B be two subsets of U. Then first bit A union B whole complement equals A complement intersection B complement. The second one is A intersection B whole complement is equal to A complement union B complement. These two properties are known as De Morgan's law. Verify okay, verify De Morgan's law. Okay, done. Verified. Okay, so now we'll discuss some previous year questions of JEE Mains. Okay, previous year questions of JEE Mains. First I done. This question was asked in JEE Mains 2025 January 22nd January shift 1. Question: let A be the set containing the elements 1, 2, 3 up to 10. Let A be the set containing the elements 1, 2, 3 up to 10. And B, the set B is defined as set of all m by n such that mn belongs to A and m less than n, and GCD of mn, GCD of greatest common divisor of m and n is equal to 1, that is m and n are relatively prime. The question is find number of elements of B. Okay, the question is find number of elements of B. Try to solve this. Very interesting question. It's a good question to solve. The set B contains all possible fractions in which the numerator is less than the denominator. Numerator is less than the denominator, and there is no common factor of m and n. The highest common factor of m and n is 1. Okay, how many such fractions are possible? The question is how many such fractions are possible if both m and n are chosen from the set A. Try to solve and send me the answer. A is the set containing the elements 1, 2, 3 up to 10. B is the set containing m by n, where mn belongs to A, m less than n, and GCD of m and n is equal to 1. And the number of elements in set B. Find the number of elements in set B. Sorry, is it 55? No. 55 is not the right answer. Try it again. 55 is not the right answer. A be the set containing the elements 1, 2, 3 up to 10. Sir, is it 31? Yes, Pratisha, it is 31. You are from which higher secondary school, Pratisha? Right answer. 31 is the right answer. Okay, let me explain how the answer is 31. Solution. Both m and n are chosen from the set 1, 2, 3 up to 10. So the denominator is greater than the numerator. Numerator is less than the denominator. So what are the possible values for n? N, yes, Khalikot, Barampur. Good. So what are the possible values of n? N can be 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Okay. So if n is equal to 2, then there is only one fraction, that is 1 by 2. If n is equal to 3, there are two possibilities. One is 1 by 3 and the other is 2 by 3. If n is equal to 4, then two possibilities, 1 by 4 and 3 by 4, since GCD of m and n is 1. So 2 by 4 should not be taken. If you take 2 by 4, then greatest common divisor of 2 and 4 is 2. Now you can take n is equal to 5. If n is equal to 5, 1 by 5, 2 by 5, 3 by 5, and 4 by 5. Okay. If n is equal to 6, if n equals to 6, then what are the possibilities? 1 upon 6, 2 upon 6, and 3 upon 6 should not be taken. 4 upon 6 should not be taken, 5 upon 6. Then n is equal to 7, 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7. N is equal to 8, 1 upon 8, 3 upon 8, 5 upon 8, and 7 upon 8. Then for n is equal to 9, what are the fractions? 1 upon 9, 2 upon 9, 4 upon 9, 5 upon 9, 7 upon 9, and 8 upon 9. For n is equal to 10, 1 upon 10, 3 upon 10, 7 upon 10, then 9 upon 10. Okay. So here the number of cases is 4, here the number of cases is 6. 6 plus 4, 10, plus 4, 14, plus 6, 20, 22, 26, 28, 30, 31. Okay. The number of cases is 31. So 31 is the right answer. I hope it is clear to you. Clear. So guys, how was the class today? All the things I explained, is it clear to you? Sauradipta, Smarnika, Krishnamai, Pratisha. So guys, rest of the things we will discuss in our next lecture. Okay. I think it is scheduled on month of November. So if the class is beneficial for you, okay, tell your friends to join the class and they should take the advantage of the free class given by you, given by the government of Odisha to you. Okay. I'll provide you PYQ solutions and I'll provide you some assignments after the end of a chapter. You can ask me the doubts. You can send the doubts to Ashutosh sir. Okay, Ashutosh sir will give his mobile number. If you have any doubt, you can send the doubt through WhatsApp. So today's session is over, right? Have a good day.